All right, this is section 3.3, and we're going to be looking at the properties of logarithms. We're going to continue our work with trying to do some work with our logarithms. All right, you should be on page 8 of your packet. First thing we're going to look at is we've got 3 rules for logarithms, and these rules will help us expand and condense expressions. They actually are used to help evaluate and to solve equations when we're given logarithms. The first one is log base a of u times v, and these are being multiplied together. Well, since logarithms are exponents, the rule is that you can take the logarithm here, base a, and separate the u and the v by addition. All this is using the multiplying like bases rule for exponents. If you multiply like bases such as x to the third times x to the fifth, you get x to the eighth. Well, we add the 3 and 5 together. Well, these are exponents. We're multiplying like bases together, so you can add their exponents. That's all that is. So subtracting, you can do log base a, let's make that base a, of u minus log base a of v. So in division here, you turn the division bar into subtracting your exponents. And the last rule that we have is when you have an exponent, that exponent is just a multiplier, so you can move it in front of your logarithm. It's n log base a of u. So those are 3 rules that we can use and help us evaluate, solve, and to do some expanding and condensing of logarithmic expressions. We have another rule here that allows us to evaluate logarithms when the base is not 10. So here when b is not 10. The rule is you take log of a, whatever the log number is, and then divide it by log of the base number. This will allow you to use your calculator. It doesn't matter which base log you use, whether it's the log button, log, so log 4 over log 3, or if you use ln of 4 or over ln of 3. Either one of those is going to give you the same result. And by calculating that, we get 1.26. So just think about this as asking you 3 to what power is 4? 3 to what power is 4? It's going to be somewhere between 1 and 2, closer to 1. We can use this rule to evaluate. So log base 7 of 4, I obviously don't know what that's going to be. 7 to what power is 4? That's not something that I'm able to do on my own or in my head, so we can do log 4 divided by log 7. And you would get your result. This is equal to 0.712. All right, here we've got log base 1/8 of 64. Many of you probably could think of this as 1/8 to what power is equal to 64 and recognize right away that the answer is -2. However, if you don't recognize that, then you can do log of 64 divided by log of 1/8, making sure you use parentheses with the 1/8, and you would get -2. All right, that's called the change of base formula. What we're going to do right now is look at trying to do some simplifying, expanding and condensing using the 3 properties for today. Use the properties of logarithms to rewrite and simplify. All right, I'm showing here inside this logarithm I've got multiplication. So I can take this and write it as addition. Log base 2 of 4 squared plus log base 2 of 3 to the 4th. Here we've got both powers. We've got 2 log base 2 of 4. And so what I do there is I take this exponent of 2 and I write it in front of the logarithm. And I'm going to take this exponent of 4 and I'm going to write it in front. Plus 4 log base 2 of 3. Right here, you got log base 2 of 4. Well, that is equivalent to 2. This is 2 right here. So it's 2 times 2. 2 times 2 plus 4 log base 2 of 3. Final answer, you got 4 plus 4 log base 2 of 3. Now you could figure out log base 2 of 3 in your calculator and then add all these values together and you would get an approximated result by using the change of base formula. All right, example B here. Your ln is a base of e. That's base e. And the 6 is being divided by e squared, so you could write it as ln of 6 minus, you're going to change the division to subtraction, ln of e to the second. Well, if your ln is base e, we don't know what ln of 6 is. That's going to be a decimal of some sort. But ln base e of e squared is just 2 because they're inverses of each other. The ln and base e are inverses. So this final result here is ln of 6, you could calculate that and get an approximated decimal, minus 2. Okay. All right, last one on this section here, this example 2, log base 9 of 27. So we could think of 27 as breaking it up into the product log base 9 of maybe 9 times 3. And since that's multiplication, you can do log base 9 of 9 plus log base 9 of 3. Log base 9 of 9 is, this is just 1, plus log base 9 of 3. 9 to 3, it's getting smaller, so it has to be a fraction. It's also a square root of it. The square root of 9 equals 3, so that exponent would be 1/2. So final answer, 1 plus 1/2 is 1.5, or 1.5. All right, so that's using some of our condensing and expanding rules that we have. Let's continue with our practice on those. Use the properties of logarithms to verify the equation. Let's go ahead and work on the right side, and we're going to show that we can get ln of 24. I know that this 3 is a power here on the 2, so it's ln of 2 to the third plus ln of 3. 2 to the third is 8, so it's ln of 8 plus ln of 3, and then you can combine those to be ln of 24. And that's what we have to show. We were trying to show that we could get 24. As you are condensing here your expression, you're starting to reduce the number of times you're writing the log. So you're taking this big expression. All right, we're going to go ahead and look at the next examples here, just trying to condense and expand, getting used to these rules. Use the properties of logarithms to expand the expression as a sum, difference, or a constant of multiple logarithms. All right, we've got log base 10 of 10z, so we can write that as log base 10 of 10 plus, since it's multiplication, 10 times z, you separate it with log base 10 of z, with addition in between them. And since log base 10 of 10 is 1, this actually equals 1 plus log base 10 of 10, or of z. Final answer. All right, on this second one here, we've got division. So I'm going to go ahead and separate that with natural log x. With the division, it's going to be minus natural log of the root x squared plus 1. Anytime you see a square root, you can represent that square root as a power of a half. So I'm going to go ahead and write over that. This is really parentheses to a half power. And you can move that in front of it. Okay, so final answer would be ln of x minus 1/2 ln of x squared plus 1. All right, that'd be as far as you'd be able to take that to completely expand it out to as many terms as possible. Here we've got three things being multiplied and divided out. So you're going to have three different logs. You're going to have log base b of the root of x, and then you can do plus log base b of y to the fourth, and then the division would be subtraction, minus log base b of z to the fourth. In your last step, you're going to want to take all of those exponents and write them in front. Final answer, 1/2 coming from the square root, log base b of x, plus 4 log base b of y, and then minus 4 log base b of z. All right, that is it. Now the next set we're going to look at trying to condense, putting them back together as an expression. So we're going to take the two logs that you have here and write it as one log. Log base 5 of, and since 8 is being with the t that's subtracting, that is division, 8 over t. This -6 is my exponent, so it's log base 6 of 2x to the -6, all of it to the -6, not just the 2, not just the x. This would become log base 6 of 1 over 2x to the 6th. I'm going to go ahead and condense that by applying my power of 6. So log base 6 of 1 over 2 to the 6th is 64, and then x to the 6th. So you're going from this -6 here being an exponent to putting it to the 2x as a -6 exponent, and then trying to simplify the -6. All right, I've got natural log of x plus 1, 2 natural log of x minus 1, or let's go ahead and put that power up on top. Put the power up there. I can put those natural logs together as the natural log of x plus 1 times x minus 1 to the second. And then you still have plus, that'd be a natural log of x to the third. I'm going to go ahead and put that exponent on top. You'd want to make sure you use this 1/2. This 1/2 means an exponent. So it's an exponent here of a half instead. And I can apply that 1/2 to everything on the inside. So my final answer would be natural log x plus 1 to the 1/2, which is the square root of x plus 1, x minus 1 squared, then to the half, these cancel, so just x minus 1. Now we have the addition of x to the third here, natural log, so I can combine it and just do multiplying that with the original x to the third. So I've combined all of the multiplication, and I took care of the power of a half. All right, we got a couple more examples to look at or go through. On the first one here, it says, well, first of all, it says find the exact value without using your calculator. So we've got 5 going to 1/25. It's a fraction. It's going to end up being -3. If you're going to a fraction, you're going to use your exponent. You can also find it by taking log base 5 of 1 minus log base 5 of 125. That is another way that you are able to do that. You get 0 minus 3, so -3. On letter B, taking log base 4 of -16, you can't do it. Okay? It's not possible to take log of a negative number. On the third one here, I would probably take these two logarithms and condense them to 1, log base 4, 2 times 32, which is 64. So that answer is 3. 4 to what power is 64? On letter D, this 6 can be the exponent in front, so 6 natural log of e minus, and you can put the 5 in front as well, that'd be multiplying it times 2, so 10 natural log of e. That's just 6 minus 10, so -4. The natural log of e, they're inverses of each other. And finally here, I'm going to write this fifth root as an exponent. So natural log of e to the 3/5. You can do that as 3/5 times the natural log of e. And the natural log of e, again, cancels their inverses, so the answer is just 3/5. Since your natural log base is e, those are able to cancel. All right, that's expanding and condensing with logarithms. And there's your assignment.